All right, we're live. Hello, this is Toby, and we're gonna continue our LLVM tutorial walkthrough. This is part 3, I think, or something. We're in the middle of chapter 2 of the tutorial. We done the sort of first chunk of chapter 2, which was defining these classes to represent the AST nodes in this language. The next part is going to be Parser Basics, okay? And here we're going to be making a recursive descent parser. Recursive descent parser consists of a series of potentially recursive functions. Usually they have some recursive element to it, which is why the word recursive is in the name. And usually there will be one function for parsing each one of the syntax elements in the programming language, and which I'll explain as we go. But I'm gonna just follow along this tutorial and type in the code that it instructs me to type. At least at this point, that's what I'm gonna do. There's gonna be a cur_toke variable, which stands for current token, which sort of remembers the current token in the stream of tokens. So remember that there's, like, let's say you have a string, which I don't know, it says something like, maybe the string says foo space equals space 5. Maybe that's the string. What's the tokenizer gonna do? Well, the tokenizer says, yeah, that is a token. That's an identifier token, and it contains this foo string within it. So that's one token. I'm gonna skip this space. That's nothing. I ignored it. This guy is a token as well, but in this lecture it just represents it as the character itself. It's not like a known token per se. It's one of these supposedly, well, it's not even, God, there's a line of comment that says like unknown tokens are represented by their ASCII code. So like if you type in an equal sign, and instead of one of these negative numbers, you actually get a positive number. You actually get a positive number, which is their ASCII code, right? So get back to my diagram. So basically, and then we have two tokens so far. One token is this ID token. The next token is this token that just is the equal sign, and then this 5 actually will get recognized as a number token, which is gonna have number 5 in it. So we actually have 3 tokens. So it's actually a stream of 3 tokens. If you can think of this as a stream, with stuff coming in from the stream. So so when you read a token, you're gonna call this getToke function. It'll give you the next token in the stream. So you get toke, the first the first token you're gonna get is this ID token. But we're gonna buffer it. We're gonna save it in this temporary variable called cur_toke, which is what this get next token does. It will call getToke and save this current token in cur_toke, to make it available for the actual parser that will be examining its value, as you will see. Okay, now we'll have a couple of functions for error reporting. I'll type them out and then hopefully can explain what they are doing adequately, although no guarantees. Printf is a print function like printf, except it directs it to a specific file. In this case, standard error. So that in JavaScript that would be like console.error. I don't know why we're returning a null pointer for this log error function, but yeah, basically it prints that out with this string passed in as the additional message to be printed out. And we have a separate function for error reporting. This looks like why we have a log error specifically for prototypes. I'm not sure about that actually. I'll just wait for later when the tutorial actually uses this function to try to explain it at that point, because at this point I honestly don't know why we have a second error reporting function. Okay, but in any case, I'm gonna copy it over. I think I misspelled pointer. Pointer should be spelled PTR. Obviously. Duh. Okay. So I have these two functions copied. Now we can actually start with the parsing. So for recursive descent parser, the pattern is gonna be whatever your symbol name is. Whatever your symbol name is, there, you slap the word parse in front of it, and that's gonna be a function that you write. So in this case, it's parse number expression, and the next one is gonna be parse paren expression, right? Let's write this parse number expr function. Auto is a keyword in C++, similar to var in C#, where it allows the developer to not have to explicitly write out the type for that variable. C++ will just infer the type of the variable, even though it's not made explicit. Make unique is a standard library function that creates a unique pointer and allocates memory to store this particular object of this class. So basically this is actually gonna have the effect of newing up this number expr AST. Except so this is like in Java you would have written, well, in C++ you can write this too actually. You can write new number expr AST, but instead of doing this new thing, we're using make unique, which has the effect of making use of this smart pointer approach. Yeah. Which I will try to explain to the best of my ability, although to be honest, it's kind of new to me. And this standard.move will basically move the ownership of this smart pointer out of this function, so that whoever is calling this parse number expr receives this smart pointer, and now they own it. They are responsible for cleaning it up. Okay, so this one is just gonna, this parse number expression is very simple because it kind of is expecting a number to already have been parsed, like a number token to already have been parsed. It doesn't even check whether the current thing is a number token or not, because it's expecting whoever calling it has already looked at the type of the current token and saw that it was a number. So yeah, let's do the next one. Parse paren expression. Okay, this one is more complicated. It's gonna, oh, it actually just expects the paren, open paren, to be the first token here and just eats it. And by the way, this term eat is something that I've heard often. Eat, the reason it's called eat. Okay. So let's go back to this tokens. We have a stream of tokens, right? A token here, token here, token here. Maybe this token is the open parenthesis, and then maybe you have this n and then close parenthesis. When it says eat, that means, well, the current token is pointing to this one right now. Eat means I want to consume this token by moving this cursor this way. So I want to move this cursor this way. That's what they mean by eat. So that we want to change the value of the current token, to be the next token, because that's what get next token does. I kind of have a problem with this this sort of idea of eating tokens and consuming tokens, and tokens have to be consumed. But I'm not gonna get into that too deeply now. I've been looking into functional parsing, and I feel like maybe that I probably prefer that approach over this. Again, we're gonna eat a token. We have already checked that it's actually I prefer to flip this conditional and have the positive conditional first. So if we can already see that the next token, or the current token I should say, is the closing parentheses, then we're gonna consume it. Oops. And also we're gonna return this v, whatever the v has returned, but we haven't defined parse expression yet. Why do we return the result of log? I don't like that. I think it would be best return null pointer. That's my opinion. But you know, I'm gonna follow the tutorial just so that I don't get confused later on, because I deviated too much from the tutorial. Okay, so if we basically, this is saying like there's a parentheses with some stuff in it, and the stuff in it, I don't know, it could be anything. It could be an expression like that, but basically it's first gonna, something outside of this function has already seen this token, and it's decided we should parse a paren expression. Now we're gonna parse an expression which should consume this part, and then take that part and put it in v. If we didn't get that, didn't work though, we're returning a null. But if that did work, we're gonna make sure the next token is the closing paren, and then we're gonna eat it. We're gonna advance this cursor. This cursor is getting advanced to whatever the next thing is after this, and then we're gonna eat it. Yeah, eat it advances it, and then we're gonna return whatever that expression was returned by the parse expression, right? But if that didn't work either, we're gonna log an error. That's what's going on. Let's move on to the next part. This time we're gonna parse an identifier expression. I think this is actually a misnomer. So I looked at it or a function call expression. So I'm gonna name it more justly. You'll see. Let me finish typing this bit. I'm gonna call this parse identifier because that's actually what it's doing. Okay. Again, it's actually assuming that whoever calls this function has already tested the fact that we just saw the current token is a identifier token. So just using the identifier string, which is supposedly only valid. It should only be valid when we are currently looking at the identifier token. This should only be valid when cur_toke is of type toke identifier. That's the technical way of saying it. I'm gonna eat that identifier token, and then now we're expecting. Oh, not expecting, but again, the guy who likes to write this, the guy who wrote this tutorial likes to do the negative conditions first. I kind of prefer positive condition first. So I'm going to do this. So if this is basically an expression that's like, it could just be like a variable, which could just be n, in which case, oh yeah, that's an identifier. And but it could be n, and then it's a function call. N is actually a function, and that's what this next part is parsing here. It's saying, oh well, I just parsed an identifier, but what if the next character right after that is an open parenthesis? Then we're gonna parse this argument list, and it's actually a call expression. And that's what this part of the if statement is gonna do. But in the else clause, it's actually just gonna recognize this guy as an identifier. So I'll do the else clause first. That's the easier case, and that's the case that I think it handled here. Yeah, so we're just gonna make a unique, again, use this make unique function to create a smart pointer to this, and this time is a variable expression AST with this ID name. Yeah, and then we're done if we didn't get a parenthesis as a next thing. But if we do get a parenthesis, then what we're gonna do is have a while loop. He did a while one. Yeah. Oh, we're gonna make a vector to store the argument first. Did we eat this? Yeah, we're gonna need to eat. So this eats the open parenthesis. This one eats the identifier, as he had comments expressing parenthesis. Now we're gonna make a vector, which again, that's like a dynamic array. It's a vector of arguments. Right? It's like an array of arguments. I'm gonna push into. We're gonna basically call parse expression. He kind of inlined it inside this if statement. I'm not gonna do that. That's just my style. So if parse expression got us something back, then we're gonna, that's a good argument, we're gonna stick it inside this vector. In JavaScript you would do array.push, in C++ you do vector.pushback. It means push it to the back of the vector. So pushing the arc to the back of the vector. But if we didn't get an expression, we're just gonna return a null pointer. And now if now after consuming this expression, if that worked, and the current token is closing parenthesis, then we're finished with reading in this this argument list. We're gonna break out of this while loop, and then we're gonna eat this token. I'm actually gonna eat this token in here. I'm gonna deviate from how he does it. Eat this closing paren. Now if however toke is a comma, which means there's more arguments. That means like, oh, actually you're calling this function with one comma. We just saw a comma, so there's more arguments. We go back to the top of the while loop and try to parse another expression, right? Parse this number 2. So if that's the case, we actually want to consume this eat this comma, and then we want to continue actually. Continue. Oh, didn't have to continue. We could just let it go, but we want to start back at the top of this loop again. But if that was not true, however, so if it was neither the closing paren or the comma, then we actually want to log this error. Yeah, expect that the closing paren or a I guess this could be a if else. I feel like it's better written, and I'm kind of deviating. I'm kind of riffing off of this code example, because I feel more confident about writing a parser like this, because I had some practice recently. But if you want to follow closer to this code, then by all means stick closer to it. And then I think finally, once we break out of this loop, he ate the token outside of this loop, but I decided to eat it right here. I prefer it this way, I think. And yeah, after that, we're gonna return this unique pointer again by using make unique of a call expr ast, and we're gonna, this is a call expression, so it's gonna have a function name, which is the ID name, plus this args, and we again need to use standard move to move this args variable to function, so we grant them ownership of this vector, basically, of this smart pointer to a vector. Okay, so that's parsing an identifier or a call expression. Let's keep going. Let's parse a primary. What the heck is a primary? So a primary is, I believe, is a unary expression. It's either there's a reason why they call it primary, although I think it's kind of confusing. It's either a number. A primary is either a number or it's a identifier, like, you know, a variable, n or foo, or it's a expression that's within a parentheses. All of these you can think of as a unary expression. There's only one. It can be paired with other things though via a binary expression. So That's what a primary is. So let's write this code to parse a primary. Whoops. Go to the end of the code. So it's gonna do a switch on the current token. It does a default first, which is quite strange. I haven't seen that before. I'm gonna do the switch at the end. So it says unknown token when expecting, what are you expecting? An expression. Okay, I'm gonna put this default clause at the end, and then, so if it's an identifier, it's gonna sort of call the parse identifier. I actually called it the parse identifier or call expression. If it's a token number, then it's gonna go to parse number expr. In parentheses, it's gonna call the parse paren expr. So this actually makes a lot of sense because it's basically saying, parse. Basically saying, oh well, we got these tokens coming in. The first token is like an ID token. Maybe the ID is foo. Well, if then I know the next token is an identifier, then what am I gonna try to, which parse function am I gonna try to call? If I call parse number, that won't work because number is expecting a number token, right? So each of these three parse functions are expecting already that a specific token type is currently what the value of cur token has. So if the current token is an identifier token, that's when we invoke this guy, this function, which is already expecting this to be the case. And that's what this parse primary is doing for us. It's based on the type of the current token, is dispatching the parsing to one of these three functions. All right, let's keep going. And we're gonna binary expression parsing. Let me think about this. Should we dive into this in this video, or should we wait until the next video? Let me see what's the length of this video. I think I'm gonna defer this one to the next video. So yeah, if you're following along, then I'll see you on the other side.